This is the question related to the MOSFET. They said calculate the bias current of M1. M1 means they are talking about the MOSFET. Okay. Then we need to they have given mu and COX is this one. VTH is the threshold voltage. They have given this one. What choices of RD place the transistor at the edge of the triode region? Okay. So basically in the MOSFET we'll have different types of region. Remember I told you active region, saturation region. So basically they are calling the active region as a triode region. Okay. There are three types of region now in the MOSFET. One is the active region, another one is the cutoff region, and another one is the saturation region. Correct? So basically they are calling active region as a triode region. So we'll have some particular values for particular region. What are the values? Like you need to write down the formulas based on this. First we need to calculate the diode current, the MOSFET current. Suppose if it's in a saturation region. Okay. So the formula for that is half mu n COX W by L VGS minus VTH का whole square. VGS remember I told you the gate to source voltage है ना, एक VDS होता था and another one is VGS, correct? So VGS is the gate to source voltage. So in this case VDS we need to calculate. VGS is the gate to source voltage, VDS is the drain to source voltage, and its formula is VDD minus ID RD. Got it? If VDS is greater than VGS minus VTH, then in that case MOSFET operates in saturation region. Okay, MOSFET operates in saturation region. This is the condition. Got it? But if VDS is equal to VGS minus VTH, then in that case MOSFET works in the triode region. Okay, triode region means the active region. Got it? If it is less than, then it works as a cutoff region. If VDS is less than VGS minus VTH, then it works in the cutoff region. Got it? So we have to determine this thing first. Every time we have to determine VDS, VGS and VTH, then we'll be able to detect which of the region will enter. Okay. So if we want to calculate VDS, if we are having another formula of VDS, that is VDS is equal to VDD minus ID RD. Okay. So let's back to the question again. What they have said, the edge of the triode region, right? So basically first they ask you the bias current of M1. Bias current is this one, right? Bios current is this one, so I'm writing the formula over here only. ID is equal to half mu n COX W by L VGS minus VTH का square. Okay, half we know already. Mu n into Cx we have given 100 micro ampere. W by L they have given, that is 2 divided by 0.18. Okay, now VGS they have given, and VTH they have given 0.4. Okay, VGS is the basically gate to source voltage. So it's a source, it's a gate and it's a drain, right? ऐसे ही होता था. This one is the gate used for controlling, this one is the source and this one is the drain. So as you can see, the voltage between gate to source is how much? 1 volt they have mentioned. So basically VGS is how much? 1 volt. Okay. देखो यहाँ पे अगर if we'll done grounded, then the gate to source voltage is how much? 1 volt. Correct? So if we'll solve it, then we'll get 200 microampere. So now from here we'll be able to get the bias current, that is 200 microampere. Understood? Now we have to see that it's a triode region. For the triode region, that this would be equal. Correct? So we should know the formula of VDS. VDS is how much? VDD minus IDRD. Now see in the numerical what we need to calculate. We need to calculate R of D. Right? So VDD, we know VDD. Let's see in the question. VDD is given, they have given as how much? That is 1.8 volt. 1.8 minus ID, we have just calculated 200 microampere, means 200 into 10 raised to power minus 6. RD value we don't know, right? Now we need to calculate VDS, correct? Then only we'll be able to get RD, है ना? Now see what is the formula for VDS. As I told you, VDS formula is VDD minus ID RD, but we should get another formula. VDS formula is VGS minus VTH, right? So let's see whether we can calculate VDS from this formula or not. VTH they have given 0.4, VGS they have given in the question, that is 1 volt, right? So VGS we got it as how much? 0.6 volt, correct? So we can put the value of 0.6 volt here. Then after solving, we'll get the RD as 6 kilo ohm. This is about the Mosfet numerical, which again, this is also from your midterm September 2020.